Hi students, I am Dr. Suresh, Assistant Professor in Physics, Vijnan's Nirula Institute of Technology and Science for Women in Guntur. Today we will discuss a very important topic, types of dielectric polarizations. There are 4 types of dielectric polarizations occurs in dielectric material. First one, electronic polarization. Second one, ionic polarization denoted by Pi. Third one, orientational polarization denoted by PO. Fourth one, space charge polarization denoted by PS. Here that implies total polarization of the dielectric material is sum of all these polarization. P equal to PE plus Pi plus PO plus PS. First, we will discuss electronic polarization, that is denoted by PE. The derivation of electronic polarization or polarizability is guaranteed essay question in exams. It is also important in competitive exams. I am going to derive it step by step, so slowly and clearly that even if you have never seen this before, you will understand every single step. Electronic polarization is most fundamental type of polarization. It occurs in every material because every material has atoms with electron clouds. Let us begin the derivation. Without electric field, in every atom there is a positively charged nucleus surrounded by negatively charged electron cloud. Generally, center of gravity for positive charge and the center of gravity for negative charge coincides with each other. That means the displacement of two center of gravities becomes zero. So there is no displacement, there is no dipole moment also. That is dipole moment also zero without any electric field applied to the atom. When an external electric field E applied to the atom, what happens? The nucleus displaced along with the direction of electric field and electron cloud displaces opposite to the electric field with a displacement x. Here the dipole moment becomes ZE equal to charge of the nucleus into displacement between the two charges is x. Here the nucleus experiences two forces. First force due to applied electric field, that is Lorentz force, you can take it as F1. Second force, external, the restoring force due to electron cloud, which pulls nucleus towards opposite to electric field E. Here you can see in figure, this nucleus experiences two forces, that is due to electric field, nucleus experiences one force, that is called Lorentz force. Other force is also applied due to electrons. These electrons will attract the nucleus, that is opposite to the electric field. These two forces are acting on the nucleus. Next, calculating restoring force, very important. The force due to applied electric field F1 is equal to charge into electric field. This is equation 1. Now we will calculate restoring force. According to Gauss law, only charge enclosed within the sphere of radius x contributes to restoring force. That is, this sphere of x, this is only charge enclosed in this sphere only contributes to restoring force. The charge enclosed in sphere of radius x is q dash is equal to ZE into x cube by r cube. This is equation number 2. How will you get this equation? Let us know. Charge density, that is charge per unit value, rho is equal to total charge divided by total volume of the atom, that is 4 by 3 pi r cube. Here r is the radius of the atom without any electric field, charge per unit atom. Now total charge enclosed in this volume, that is 4 by 3 pi x cube. The volume of the atom with applied electric field is 4 by 3 pi x cube. The total charge enclosed, that is q1 equal to 4 by 3 pi x cube, volume of this atom, into charge density, that is ZE divided by 4 by 3 pi r cube. Here 4 by 3 pi cancel each other. Then q1 we will get ZE into x cube by r cube. The restoring force, now restoring force according to Coulomb's law, it is F2 is equal to 1 by 4 pi epsilon naught, charge of the nucleus, charge enclosed in the surface, that is ZE into x cube by r cube, divided by distance between the two charges, that is x square. This is equation number 3. That is F2 equal to 1 by 4 pi epsilon naught ZE into Z x cube by R cube divided by x square. Then the F2 becomes, upon solving, restoring force F2 equal to Z square E square x divided by 4 by 3 pi epsilon naught R cube. This is equation number 4. This force acts in direction opposing the displacement. It is restoring force like spring force. F2 is this like spring force. At equilibrium condition, let us consider equilibrium condition. These two forces F1 is equal to F2. That implies F1 is equal to ZE into E, F2 equal to Z square E square x divided by 4 pi epsilon naught R cube. Upon solving, Z will cancel each other, E square cancel each other. Solving for x, then x equal to, that implies x equal to 4 pi epsilon naught R cube E divided by ZE. This is equation number 5. Here x is proportional to E. That means larger field. If you apply larger field, the displacement is also larger. Next, calculate induced dipole moment. We already know nu E equal to ZE into x. Here we already know from equation 5 x value. Substitute in this one. That is ZE into x value is 4 pi epsilon naught R cube E divided by ZE. Here ZE value cancel each other. Then mu E is equal to 4 pi naught R cube E. This is equation number 6. Next, electronic polarizability. Calculation of electronic polarizability. That is alpha E. Electronic polarizability units are farad per meter square. Already know. We know the relation between dipole moment and electronic polarizability. Nu E is equal to alpha E into E. Then above, from the above equation, we can calculate alpha E. That implies alpha E is equal to nu E divided by E. That implies nu E value is 4 pi epsilon naught R cube E divided by E will be cancelled. Then the electronic polarizability value alpha E is equal to 4 pi epsilon naught R cube. This is our final expression for electronic polarizability. This is equation number 7. Here we already hear from this equation alpha E, that is electronic polarizability, directly proportional to R cube. That implies, it means larger atoms with more loosely held out electrons are more easily polarized. This is why noble gases, that is noble gases, polarizability increases from helium to xenon. Helium has, radius of helium is less, so electronic polarizability less. But radius of xenon is large, so electronic polarizability is large. Next, calculation of electronic polarization, that is PE. We know PE is equal to N into alpha E into E. This is a formula for polarization, total electronic polarization. Here, so electronic polarization PE equal to N into alpha E. From equation 7 we are 4 pi epsilon naught R cube into E. This is total polarization, electronic polarization in the material, where N is number of atoms per unit value. Summary of this class, this is the final expression for electronic polarization, that is N into 4 pi epsilon naught R cube into E, where N is number of atoms per unit volume, epsilon naught is the permittivity of free space, R is the radius of atom, E is the applied electric field. Here the summary of this class is, electronic polarizability is not depend on the temperature, it depends on the radius of the atom. It occurs at 10 power 15 Hz up to 10 power 15 Hz. The responsive time is 10 power 15 seconds minus 15 seconds. This is about all about electronic polarizability. In next video, we will discuss about ionic polarizability, which occurs in ionic crystals like sodium chloride. So we will see in next class. Please subscribe, share and like this video. Thank you everyone.